I'm Nova.
I'm Alloy, and this is AgentStack Daily.
OpenClaw shipped 2 correction releases that stop codex turns from ending after a progress message, repair certain memory startup conflicts, and restore official plugin updates with newer package clients. Hermes Agent 8.3 is much bigger, real-time voice with streaming speech, interruption support, wake words, and agent-to-agent communication. The terminal-based AI coding agent Claude Code also shipped 0.220, although its source gives us a stable tag without concrete release notes. Beyond the harnesses, Circles says OpenAI-powered telecom personalization raised revenue per user 22% and cut churn 9%. Researchers are also building video agents that inspect actual footage instead of guessing from a title.
Okay, that last one shouldn't feel revolutionary, and yet here we are. Today, you'll hear what changed in OpenClaw 7.1-2 and 7.1-1, why Hermes 8.3 is such a substantial expansion, what Qwen 3.8 Max promises for coding and Cowork, and whether AirLLM's claim of running a 70 billion parameter model on a 4 GB GPU translates into useful performance. There are also open safety models, robotaxi reasoning, a widening Apple OpenAI legal fight, faster long video systems, continuous voice engineering, and open infrastructure for agent research.
OpenClaw 7.1-2 fixes official plugin installation and updates. Newer package clients can return plugin metadata inside a one-item array rather than as a single object. OpenClaw now accepts that shape, so tracked official plugins can receive correction releases. OpenClaw 7.1-1 carries 3 more repairs. Progress messages from the Codex app server no longer cause a turn to stop early. OpenClaw keeps the turn alive until GPT or Codex produces its authoritative final response. That's consequential because a progress update says work is continuing, not that the task is finished. Memory core can also recover from conflicts involving an older derived index and its cache sidecar instead of trapping the gateway in a fatal restart loop. Structural corruption in the vector store remains retriable. Finally, under Windows Subsystem for Linux, guarded permission changes may return a read-only file system error. OpenClaw tolerates that only when the existing state path is already private, broadly permissive paths still fail closed.
I like that distinction. Make it start would be easy if the fix simply weakened the safety check. This one preserves the permission boundary. Hermes Agent 8.3, identified by its maintainers as version 0.20, operates at a different scale. The release covers roughly 3,650 commits, 1,400 merged pull requests, 5,200 changed files, 559,000 insertions, 405,000 deletions, and 1,200 closed issues, with more than 650 contributors. Those are development totals, not 1,400 promised features. The named capability is real-time voice with streaming text-to-speech, barge-in so a person can interrupt, on-device wake words, and hands-free control across the terminal, desktop app, and audio-capable gateway platforms. It also supports A2A version 1, a standard through which separate agents can exchange work.
And that pairing changes how Hermes can operate. Voice isn't merely a read-aloud button when the system continuously listens, begins speaking before the complete answer is rendered, and yields when the person interrupts. Wake words let it remain available without a keyboard. Agent-to-agent communication lets the speaking agent carry a request elsewhere rather than perform every job locally. Still, the enormous code totals don't prove a quantified reliability or speed improvement. The Herald release is the maintainer's name, and for once the mythology is literal. Hermes now speaks and carries messages.
The terminal-based AI coding agent Claude Code ships stable release 0.2202. The available source establishes the release but doesn't supply a concrete changelog, so there's no feature story to manufacture from that number. The honest read is uneven. OpenClaw closes specific failures around plugins, codex completion, memory startup, and protected state. Hermes gains broad voice and interagent capabilities. Claude Code has a stable build without enough source detail to claim more. Qwen calls Qwen 3.8 Max a new bar for coding and Cowork. What does Cowork mean here beyond a very fashionable label?
It means multi-step agent work alongside a person rather than one prompt followed by one answer. Qwen released the flagship on August 4 and says it moves beyond earlier Qwen models on coding tasks and longer-running collaboration. That puts repository inspection, multi-file edits, tool use, feedback, and human redirection at the center of the pitch. Its Hacker News discussion reached a score of 1,102, unusually high attention for a model launch. That number measures interest, not quality, but developers clearly noticed the coding and Cowork framing. The meaningful question is whether the model can preserve context and intent through a long task when a person changes direction midway. The launch material leaves important engineering details open. It doesn't give a context limit, tool call reliability rate, edit success measure, or deployment timetable. Those omissions don't erase the launch, but they keep the model's long-horizon performance unproved. I'm excited by that category, but I don't buy new bar yet. The phrase comes from Qwen, and the supplied launch material doesn't include a separate benchmark package, detailed feature table, or pricing sheet that settles the ranking. Independent evaluations need to compare Qwen 3.8 Max with other flagships inside actual coding agents, especially on long jobs where one bad edit can compound several steps later. Distribution matters too. A strong model isn't very useful if it takes months to reach the products where people work. The attention is real. The performance crown remains Qwen's claim. AirLLM advertises a startling result: Inference with a 70 billion parameter language model on one GPU containing only 4 GB of memory. That's older laptop or budget desktop territory, not the hardware normally associated with a model that large. The open-source repository drew a Hacker News score of 230 after surfacing on August 4 because the economic promise is obvious. If useful local inference really fits that hardware, people could access much larger models without a data center or costly multi-GPU machine. But Fitz is doing Olympic-level work there. A model can technically execute while remaining far too slow for an interactive assistant.
Exactly. The headline gives memory capacity, not useful latency, throughput, or energy use. The supplied material doesn't include release notes that establish the current technique, so we can't responsibly invent how AirLLM moves or stores model data. This matters most for older workstations, edge systems, and deployments where accelerator memory dominates cost. Yet the decisive numbers are how long the first output takes and how quickly later tokens arrive. Memory fit, first output delay, steady generation speed, and storage traffic are separate constraints. Clearing one doesn't clear the others. Without those figures, 70 beyond 4 GB is an impressive compatibility claim, not proof of a pleasant product.
Okay, it's potentially wild, but it's different from a compact local model. A small model requires less computation in the first place. AirLLM claims a very large model can cross a severe memory boundary. One may support fast private assistance on ordinary hardware, while the other may make a larger model accessible for slower or specialized jobs. The materials don't establish which experience applies here. Performance numbers still have to answer whether this is conversation, batch processing, or simply successful execution.
Here's the deployment result I kept coming back to. Circles reports average revenue per user up 22%, churn down 9%, and improved development efficiency from an OpenAI-powered telecom stack. Those are company-reported figures published in OpenAI's newsroom, not independent measurements, but they target outcomes carriers care about deeply. Revenue per user shows how much value each subscriber produces. Churn measures how many subscribers leave. Moving both favorably says much more than claiming people engaged with a demo.
Circles builds personalization systems for telecom carriers and sits between those carriers and their subscribers. It says it uses the OpenAI API together with Codex for AI-native telecom experiences. The stack appears on both sides. Codex supports the engineering process used to build features, while OpenAI models help produce customer-facing personalization. Telecom personalization has often meant fixed customer segments paired with manually configured offers. More dynamic tailoring could change which plan, service, or message reaches each subscriber while shortening the development loop.
That connection matters, but I want the deployment map. The account doesn't name the specific carriers, countries, sample size, measurement window, or comparison baseline behind those percentages. A lift across several mature markets means something different from one tightly scoped rollout. Circles says the system ran and produced commercial results. The uncertainty concerns attribution and transfer. How much came from the models, how much from product design, and would another carrier see the same gains? The two reported business outcomes also reinforce each other. Higher revenue per subscriber is more persuasive when fewer subscribers leave, because the gain isn't merely extracting more money from a shrinking base. Even with that vendor case study label attached, 22% is large enough that competitors will pay attention.
Mistral released Shieldstraw on August 4, a 3 billion parameter open-weights classifier that evaluates safety across images and text. Mistral says it outperforms classifiers as large as 7 times its size. That number comes straight from the company, so I'm treating it as a claim until someone outside Mistral reproduces it. The release still addresses a real product problem. Multimodal services must judge whether the image, the words, or their combination crosses a policy boundary.
And 3 billion parameters is unusually approachable beside the giant models we've discussed. Because the weights are available, organizations can run Shieldstraw in their own environment and adapt it to a domain-specific safety taxonomy. A healthcare platform, game, and social network may define harmful or restricted material differently. An open model gives them more control over labels and tuning than a closed moderation service. It may also simplify pipelines where separate classifiers inspect images and text before application code reconciles their decisions. That joint view matters when neither input is unsafe alone. An ordinary caption can change meaning beside a particular image, while a harmless image can become abusive when paired with targeted text. One classifier can judge the combined context directly.
I'd keep one eyebrow raised on simplify. Publishing weights doesn't prove coverage across every language, image type, policy edge case, or adversarial input. The Hacker News thread reached 421 points, which shows interest rather than safety performance. Still, Mistral has delivered a compact, inspectable starting point for combined image and text moderation. Privacy-sensitive products can keep content inside their own environment, and outside researchers can inspect the artifact directly. Shieldstraw can't decide what a company ought to permit, but it makes the enforcement layer more controllable.
NVIDIA opened Alpamayo 2 Super for commercial use on August 4 and aimed it at robotaxis and other autonomous vehicles. Why emphasize reasoning when driving systems already detect objects and predict motion?
NVIDIA says the hardest remaining situations aren't routine lane markings or ordinary traffic. They're rare, long-tail events that are hard to anticipate and underrepresented in training data. A vehicle may need to understand an unusual scene, infer cause and effect, and choose an action when familiar patterns don't apply. Alpamayo 2 Super is presented as a frontier open model for that layer of driving. Commercial availability lets vehicle teams treat it as a foundation for product development rather than only a research artifact they can inspect.
That's exciting, and also where open can sound more reassuring than it should. Robotaxi reasoning sits inside a larger system of sensors, perception, prediction, planning, controls, simulation, and safety checks. The announcement doesn't explain how Alpamayo 2 Super plugs into existing vehicle stacks, what exact licensing conditions govern commercial use, or how it compares with closed alternatives on safety-critical evaluations. A foundation model may interpret a strange scene, it doesn't independently make a vehicle safe.
Right. Commercial access is concrete, proof that long-tail driving is solved is not. Making the model available can broaden who studies rare situations and reduce duplicated foundation work across autonomous vehicle teams. It also shows NVIDIA shifting emphasis from routine perception toward contextual reasoning and action selection. Perception might identify a stopped vehicle and an open door. The reasoning layer must connect those facts to a person who may step into traffic, then choose an action. That is the kind of causal chain the announcement is targeting. It could accelerate development, but the stakes are higher than coding benchmarks. Errors here meet roads, passengers, and pedestrians, so deployment evidence matters far more than the word frontier. Apple says its trade secrets investigation now reaches additional former employees who moved toward OpenAI. In a supplemental court filing reported on August 4, Apple claims more former staff may have retained or accessed confidential information. This expands an existing matter rather than opening a separate case. The public record cited here doesn't name those employees or identify the categories of information Apple alleges were taken. The widening investigation is factual. The conduct remains an allegation.
And it widens the human stakes. AI companies are recruiting people whose expertise was developed inside other large technology firms, while those firms are increasingly willing to litigate over what knowledge traveled with them. Engineers can carry skills and experience to a new job. They can't carry an employer's protected files or trade secrets. The hard disputes often concern where that line sits when valuable material includes technical plans, internal research, or remembered operational knowledge rather than a cartoonishly labeled secret folder. Because the additional employees and alleged information remain unnamed in the public account, the filing broadens the dispute faster than it clarifies it. Scope is expanding, evidentiary detail is not yet keeping pace.
Apple's filing doesn't establish that OpenAI received or used anything improper, and the unnamed scope makes public interpretation harder. It does mean the matter is no longer confined to previously identified people. If the court accepts the expansion, that can bring more messages, records, and employment transitions into discovery. This also leads directly into OpenAI's public rebuttal. Apple is broadening allegations through court filings while OpenAI publishes its own narrative. Different arenas, different standards.
This paper calls out an embarrassing shortcut. Many supposed video agents rely on a title, web search, or memorized background rather than inspecting what appears on screen. Video deep research reverses the order. It scans relevant frames first, then performs web research grounded in what it observed.
The 35 billion parameter system was trained first from worked examples and then through reward-based training that favors finding the answer over guessing from memorized knowledge. On a new 200-question video reasoning benchmark, the authors report 64% accuracy, ahead of Claude 4.5 Sonnet, GPT-5, and Gemini 2.5 Pro. That's a paper result on the author's benchmark, so broader reproduction matters.
Still, watching the supplied footage before searching the web is the right behavioral distinction. It could help with long tutorials, recorded procedures, or surveillance clips where the answer depends on visible events. Searching a title first may be efficient. It's also how an agent confidently describes the video it expected rather than the one it received. OpenAI isn't waiting quietly for Apple's framing. On August 3 it published Apple is getting this wrong, called the lawsuit baseless, and presented messages and records that it says contradict Apple's account. The Hacker News discussion reached 277 points, so the dispute has escaped the legal audience. OpenAI describes the post as a factual correction, although selecting the headline, documents, and timing is plainly public positioning too.
Absolutely. OpenAI's documents support OpenAI's version. Publishing them doesn't turn them into a court finding. The post focuses on employee conduct and what the company says happened, not detailed legal mechanics. That gives reporters and observers material to compare with Apple's filings, but the two accounts don't resolve each other. Apple says its investigation has expanded. OpenAI says the lawsuit is baseless. Both positions can exist before a judge determines which allegations have adequate support.
Does litigating in public help OpenAI, or does it create more material that can be scrutinized later?
Both. It can protect recruiting and reputation by contesting Apple's narrative immediately. It also locks OpenAI into an account that lawyers, journalists, and Apple can compare with later filings and produced evidence. The post's attached messages are primary material, but the company chose which messages to publish and how to frame them. That makes them more informative than an unsupported denial without making the selection neutral. If the shared messages enter the formal case, their full context will matter more than either company's excerpts. Another sharp blog title won't settle this. A court ruling, named employees, or documents tied directly to the alleged secrets might. EcoFrame tackles the cost of understanding long video without retraining the underlying model. Fixed sampling chooses a handful of frames in advance and can miss the important moment. Agent-style systems repeatedly reason about where to look, but that back and forth is expensive. EcoFrame monitors confidence and retrieves additional frames only when uncertainty rises.
It changes its search as well. When attention remains spread across the video, EcoFrame keeps looking globally. When attention concentrates in one region, it zooms into that area. Across 3 long video benchmarks, the author's report speeds up to 13.5 times faster than the agent-style approach while matching its accuracy. That's the paper's result, not a universal guarantee, but it directly addresses response time and compute cost.
And it complements video deep research. One grounds answers in footage before outside search, the other reduces how much footage needs to be loaded as confidence changes. The code is public, and its training-free design lets the framework wrap an existing video model rather than requiring a newly trained one. OpenAI published an account on August 4 addressing incidents connected to third-party cybersecurity evaluations of its models. The company says it's adding safeguards for how outside cyber testing will be conducted. This isn't a model upgrade, API feature, or change to end-user prompts described in the source. It concerns the rules and controls governing external researchers and firms that probe OpenAI systems for security behavior.
That sounds administrative until an evaluation crosses a boundary. Outside cyber research can expose dangerous capabilities and weaknesses an internal team missed. It can also involve powerful models, sensitive techniques, ambiguous authorization, or actions affecting real systems. OpenAI's decision to discuss incidents publicly acknowledges that outside evaluation needs more than an informal invitation followed by a report.
The unresolved part is operational detail. The account says safeguards are changing but doesn't explain every distinction between sanctioned work and unauthorized probing, what access evaluators receive, how incidents are escalated, or what future disclosures will contain. I don't think a declared framework answers those questions by itself.
Nor should stronger controls make independent review ceremonial. If evaluators can inspect only what a lab already expects, external scrutiny loses value. If access is loosely controlled, cyber-capable models create genuine hazards. OpenAI is formalizing that boundary after actual incidents. The unanswered governance questions include who authorizes a project, which real systems remain off-limits, how unexpected capability is escalated, and when affected parties are told. The source announces stronger safeguards without specifying those controls. Other labs will watch because third-party evaluation is becoming part of model assurance, and a mishandled engagement can damage researchers, providers, and the public at once. OpenAI says GPT-Live took 6 months to build around a turnless speech model and a low-latency architecture. Turnless sounds like marketing unless we explain it. What actually changes?
It treats speech as a continuous flow rather than requiring a clean user turn, a pause, and then an assistant turn. Conventional voice interfaces often wait for silence, transcribe a completed utterance, send text to a model, generate a reply, and only then synthesize speech. A turnless design accommodates interruptions, partial thoughts, and the messy rhythm of conversation. Its low-latency architecture aims to shrink the gap between speech and response. The 6-month build signals that latency is a whole system problem. Audio intake, model inference, interruption handling, and speech output all contribute to whether the exchange feels immediate. OpenAI doesn't publish latency figures or benchmarks in the supplied engineering account, so faster and more natural remains the design goal rather than a measured comparison. That connects neatly to Hermes 8.3. Hermes exposes barge-in, streaming speech, wake words, and hands-free use at the agent product layer. GPT-Live describes OpenAI building a dedicated model and system for continuous voice underneath its assistant. Different products, same bet. Spoken AI can't feel conversational if it behaves like a walkie-talkie with a long processing delay. People interrupt, correct themselves, and say no, the other one before the system finishes. I'm excited by the direction, with one reservation: fluidity can make a system feel more competent than it is. A natural voice and quick interruption don't make an answer true. OpenAI presents this as an engineering account, not a new integration surface, and supplies 2 firm choices without a performance table. Still, it shows that continuous speech is becoming a first-class model problem rather than a transcription wrapper around text. Microsoft Research released Orchard on August 3 as an open framework for training and evaluating AI agents across different task types. Its pitch is reuse. Research groups repeatedly rebuild environments, agent scaffolding, and evaluation machinery for each experiment. Orchard offers a shared foundation so more effort can go into the agent and task rather than reconstructing the surrounding apparatus. Microsoft also emphasizes helping smaller models deliver strong results when supported by consistent infrastructure.
I can hear the objection already, another agent framework. What makes this more than a new folder structure around model calls?
The intended use is comparative research. When 2 agent experiments use different environments, tool interfaces, stopping rules, and scoring code, a headline score may hide substantial differences. Reusable infrastructure can reduce accidental variation and make task runs easier to compare. The source doesn't establish Orchard as an adopted standard, though. It establishes an open starting point from Microsoft Research. Adoption will decide whether independent labs contribute environments and report results on a common surface.
That contrast with Qwen's Cowork framing is useful. Qwen sells a model's ability to execute longer work. Orchard tries to make experiments around such agents less bespoke. Better agents need capable models and credible comparisons. The smaller model emphasis matters because a compact model can look artificially weak when its tools, environment, or stopping rules are poorer than a larger model's. A shared framework can hold more of that surrounding machinery constant. Orchard isn't a benchmark authority merely because Microsoft released it, but shared infrastructure can influence which agent claims later survive scrutiny and reach products. The fuller Qwen picture is ambitious. Alibaba describes Qwen 3.8 Max as a 2.4 trillion parameter open-weight model built around autonomous coding, long-horizon execution, multimodal feedback, and aggressive pricing. Early published evaluations place it highly on human preference and vision tasks, including claimed parity with Claude Opus 4.7 and strong object detection. Those are early claims, not a settled ranking.
2.4 trillion needs context. Models at this scale commonly use a mixture of experts design, meaning only part of the network may activate for each piece of input. That reduces computation compared with activating every parameter, but deployment still demands substantial memory, networking, serving software, and accelerator capacity. Open weights permit outside inspection and independent deployment in principle. Local can still mean a serious cluster, not the 4 GB card from AirLLM's claim.
Which is why the expected 27 billion parameter Qwen variant may matter disproportionately. Smaller open models can reach more organizations, run at lower cost, and support private deployments without flagship-scale infrastructure. Chinese labs including Kimi, DeepSeek, GLM, and Minimax are pushing open weights, while DeepSeek V4 Flash is being discussed as a cost and performance challenger for agent workloads. Competition increasingly concerns which capability level can be served economically, not only who tops a benchmark.
One caveat: the supplied accounts discussion of weight controls describes a company policy position, not enacted law or another model feature. Open weights allow inspection and deployment under the applicable license. Restricted weights remain with the provider. Qwen 3.8 Max is notable for scale, coding ambitions, multimodal feedback, and price positioning. Whether it sets a new bar depends on independent performance, real serving costs, and how much capability reaches products people can actually use. Nanobot leads with 46,651 stars on its first tracked appearance. Release 0.3 shipped July 25, and the repository was updated August 5. It's a self-hosted Python personal agent framework with a web interface, tools, memory, automation, chat apps, multi-agent workflows, and model context protocol support. Codebase memory MCP complements it by turning source code into a persistent knowledge graph across 158 languages. Its maintainers claim millisecond scale indexing, sub-millisecond queries, and 99% fewer tokens from one static binary.
Those projects fit together. Nanobot supplies the agent shell, while code-based memory supplies specialized code intelligence that compatible agents can call. Code-based memory had 37,550 stars and shipped 0.9 in July. FastMCP sits underneath both as a Python toolkit for building model context protocol servers and clients. Its 3.4 release shipped in July, and it had 27,072 stars. One project runs agents, one gives them durable code understanding, and one makes their tool connections easier to implement.
That's a healthy composable stack, although the numbers need labels. All three are first tracked appearances, so there's no 30-day growth trend, and Codebase Memory's performance figures are maintainer claims. Each repository does have a recent release and continued activity. Together they show agent frameworks, memory systems, and tool protocols separating into reusable layers instead of one product owning everything.
Model Progress today landed through flagship claims, specialized safety and driving systems, serving experiments, and domain adaptation rather than a newly material general-purpose name across major provider catalogs. Qwen drove the broad model movement. Much of the interesting work came from making models usable in specific products and hardware settings.
Minimax H3 is trending as an open video generation model with 2,300 likes. It accepts combinations of images and text and can generate or transform video across text-to-video, image-to-video, mixed prompt, and video-to-video uses. Its listed capabilities also include producing audio-video output from text, images, mixed prompts, or existing footage. The artifact uses the diffuser's ecosystem and Sapphire Tensor's format.
0 recorded downloads makes those likes an interest signal, not adoption evidence. Still, the range is notable. The model is presented for generating footage, animating images, editing video, and creating audio alongside it. The supplied record doesn't establish hardware needs, benchmark quality, context limits, or license terms. Minimax H3 stands out for multimodal breadth, not demonstrated usage at scale. Luffy the Fox's Qwen 3.635BA3B and censored Genesis Hermes v7GGUF has 308,857 downloads and 371 likes. It combines vision, multimodal input, Hermes tuning, mixture of experts architecture, and a format widely used by local runtimes. Liquid AIs deploy local agents everywhere with LFM 2.5.2.6b targets the same pressure from another direction, a much smaller model intended for agents on local devices. One packages a larger community build, the other pushes compact deployment.
GitHub's customize the reasoning level for Copilot Cloud Agent adds control at the hosted end. People delegating a task can choose the reasoning level for supporting models, trading deeper effort against resource use instead of applying one setting to every job. Across the three, local model packaging, compact on-device agents, and cloud coding agents are all exposing more choice over where computation runs and how much work a task receives. For the release details, research references, repositories, and model pages behind these stories, look at the show notes at tobyonfitnesstech.com.
Thanks for listening to AgentStack Daily. We'll be back soon.